All right, we're now going to go through the alternative method for maximum flow. So this can take longer, but usually works every time. So the advantage of this is it kind of verifies for us that we have achieved the maximum flow. As opposed to something like the minimum cut method, as we saw up here, we found the minimum cut, we said it was C3 and C4, but can we be absolutely certain that it wasn't another cut that we just didn't consider? It's a little bit of trial and error. When the alternative method, it kind of verifies for us usually every time that we've got the right answer, but it does take longer. So let's read through these steps and then we'll go through an example. So again, as I'm reading through the steps, you might be thinking this doesn't make a whole lot of sense, but once we go through the example, it will make sense. Okay, so what is the alternative method? So each path from start to finish is considered. If vertices are not labeled, start by labeling them alphabetically. Then you have to list a possible pathway, then note its minimum value. Subtract this minimum value from each edge on the path, then list a second possible pathway, again noting its minimum value and again subtracting it. Continue until there are no possible paths from start to finish with a minimum value greater than 0, and then finally you want to add all the minimum values from your path. This is the maximum flow of the network. So those are the instructions on how to do it, and we're now going to jump into an example, and hopefully it'll make sense of these instructions.